where we were involved were uh, were quite interesting. So in the next 15 minutes or so, we'll have a brief debrief from the chairs of the various breakout rooms. And first up is Associate Professor Jinman Kim from the Medical Imaging breakout room. Sorry, we're just going to unmute you.
No problem. Okay, thanks for that. Yeah, so it was we had a great meeting. We had Jan. I'm not sure if they're both here, but we had Jan Chai from Royal North Shore Hospital, and we had Greg Wheeler from Ashnew. Do you remember where it was? I didn't list down his institution, but we had, and then we had the members from our training center team. And in conclusion is there's always opportunity to use AI and machine learning and image processing to help interpret and I guess make use of large volume of data, that's image data that's being collected across all the institutions and hospital. And we had a couple of specific areas that came up. And one was, how do you evaluate the accuracy and correctness of an AI algorithm? And we talked about we still rely and the standard accepted ground truth is clinicians who label the images and classify the images, and comparing our AI algorithms to those clinicians' manual labels is still the accepted standard. We talked about how important it is to look at the level of expertise of the clinicians in their labels. And there's been recent studies where from a junior doctor to a very experienced doctor, the quality of the label is very, very large. And so it was good to take that into consideration and the need to have multiple clinicians to provide a ground truth so we can, in a way, average and take into account of their level of experience. We had other question on studying bone density. Is there AI algorithms that let you now accurately characterize bone density? We believe there is. We haven't personally experienced it, but by looking at literature, I mean, we were searching in real time as we were talking. There seems to be an opportunity to estimate bone density using image processing or using AI algorithms. I think that was a great area to explore. And then we had a big discussion on what AI tool is possible to help curate data. So people have lots of unstructured image data together, sometimes just image that's completely separated from the clinical outcomes. Some might not even have clinical outcome associated with it. It's just coming with your EMR reports. Is there algorithms and is there research interest in trying to curate that? And it's certainly a great problem. If we can get a statewide or a big support to say our research is to make imaging data to be curated so it can be used for clinical diagnosis to build up decision support system for further research, then I think this is something that technologies are able to try to address and solve. And then there was one on what is the capacity of AI algorithms on using imaging data, and my short response was as many as you can. We have seen, and there's been publications, and even within our labs, we've been able to use hundreds of thousands of medical imaging data to build our algorithms, and that's not an issue. And then it was also talk of what sort of format and what sort of compression and quality of data, and of course, we try to work with what we have, but then if we can capture the raw images and the raw DICOM format, it's always better in building our algorithm. And finally, we looked at is there technologies to help you understand the temporal sequence of data. So what patient over many years maybe have 10 different MR scans, is there a way to fit all of that to detect changes? And in fact, this is a hot area in medical image processing, and we have many good work on that, and it's certainly possible. You can track, you can register automatically, and then you can try to quantify changes in major both structure as well as say abnormal sites. So that's kind of summary, and I'm really looking forward to following up and see where we can go with it. Thanks.
Thanks, Jim-Man. It seems like you had a very interactive and very fruitful session. Could I please invite Colin to do the debriefing for the biomaterial session? Colin?
Colin,
Yeah, can you hear me?
Yeah.
Yeah. We were a small group in our room, and I think we had some good discussions. I think one which was sort of out of the box was to discuss perhaps connections between the art world and our research and discovery programs. And so that was interesting how you could, modern art likes to take a more complex view of form, looking at the inner as well as the outer aspects. And there's a lot in what's done in our research and what's being presented today that highlights that opportunity and tools for artistic expression. So that was one area that we thought would be really interesting to pursue further. We also talked quite a bit about the challenges of arthritis and how that can be addressed, and what is the challenges of such a desert like that the joint space is, especially when there's like arthritis and damaged tissue, and there's cytokines and cell invasion, all of those things happening to actually produce an anabolic reparative effect, regenerative effect in that situation is very challenging. So we did discuss a little bit the importance of catching things early, and perhaps having a sort of multi-stranded approach. So, you might be looking at combinations of materials, cells, biologic, to produce an environment within the joint that is pro-regenerative rather than destructive. I think they were sort of perhaps a couple of the main topics that we were looking at. Would you say anything you'd want to add to that, JJ?
No, I think you summarized it really well. I think all of these things, I think probably the central thing that came out of it is how do we specifically design biomaterials with specific functional properties to be able to use it as a platform, either for studying the interactions between cells or for it to be used as a delivery platform for therapeutics to address all of these problems. But yeah, I think we had a pretty diverse but very interesting discussion in our room.
Hey, thank you very much, Colin and JJ. Our final debrief is from the Biodevices breakout room, and it'll be given by Professor Alistair McEwen. Let me just unmute.
Hi, can you hear me? Great.
Yep.
So yeah, we had a very large group. We spent a long time meeting each other, which was great. I think it's really amazing at an organisation like Sydney Uni, where you meet these people after many years. You don't know that there's these people doing interesting things in the same institution. We had Leslie Nicholson, who told us about it's like a hypermobile syndrome. It's a genetic syndrome. I think it's called Ehlers-Danlos syndrome. Looking it up on Wikipedia at the moment. This is something that devices could be used for sure to look at this. It's a very interesting group of people who don't like too much things on their skin or things like that as well. So it's a really challenging group to work with. Reminds me of working with kids as well. And kind of at another end of the spectrum, we had Monia looking at some invasive measurements, kind of working on that problem that David introduced us to in the main session about the measuring forces in the knee. So Monia is looking at that with some really advanced instrumentation like fiber Bragg grading optical fibers and things like that that are used, you know, in the Sydney Harbour Bridge and other big structures to look at what's going on there in terms of forces. And then there was an interesting discussion that a lot of us were involved in, I think, around you know, how we could do some of those measurements on the surface. And I think that there's a lot of technologies around and things to think about trying, and we need to build those projects. Che talked to us about his research with multiple sclerosis and FES and getting people to do more exercise. Alan Fu told us about another project to use a accelerometer inertial measurement unit post-surgery of the ACL in the knee again. We heard a bit more from Vasi about the challenge in the older population and falls. And along with, I think it's Alicia's project, we were talking about using a sock that we know that you know, some colleagues have looked at using in some populations, a smart sock that has instrumented sensors. So we're looking at wearables and looking at also clothing that has sensors integrated into it. That was actually a suggestion, I think, by Nyan. So Alicia was talking about smart shoes, like we heard about in an earlier talk. But the smart shoes have some limitations. So how about smart socks? Alicia's very interested in shoes, footwear, and particularly dance. Let's see who else. Joanna told us about her interest in spasticity, particularly around in the stroke population. And I'm just running through all the names in front of me again to see who I've missed. Susie was there telling us about her project with Che. There was Thomas, who is looking for an honours project. At the moment, he's working in a bionics lab that works on the bionic eye, but he's looking for an honours project, I believe. And we had a couple of other speakers from the other sessions. So I think we to summarise, you know, we're really looking at this problem around the knee. We know that's a clear area where there's lots of these problems. The hypermobile, you know, it would be a problem with hypermobile joints as well. And what are the kind of sensors we could use there? And I think really this idea of smart socks could be a smart sock that goes over your knee, like some of the knee supports people wear, or a wearable on the skin with some of the technology that Jet is working on in our lab. And I think there's a real opportunity here to get an understanding from the invasive measurements and understand what, you know, as an electrical engineer would look at this problem, we would say, what's the signal size from an invasive measurement? And then how small will that signal be by the time you measure it on the skin? So if it's a mechanical or electrical or an optical signal, what's that signal attenuation? And do we need something like a nano robot contrast agent to boost it or not? And if so, you know, when and what should we use? So I think it's great to meet all these new people, and it was an exciting session. Thank you, everyone.
Thank you, Alistair, and thank you all to